stargazers, gather round. Exciting news. Astronomers have just finished mapping two pairs of stars outside our Milky Way galaxy that are feasting on their stellar neighbors. This breakthrough not only enhances our understanding of stars in general, but also aids in measuring distances across the night sky. Did you know that over half of the stars in our Milky Way exist in pairs? While it's likely that other galaxies have many binary stars as well, they are often too faint to observe. However, the so-called symbiotic stars, where one star consumes the other, are incredibly bright and much easier to detect. By studying the orbits of these symbiotic systems, scientists can gain insights into whether other galaxies form binary stars similarly to those in our own. When stars are born together, they can age differently depending on their masses. The more massive star burns through its fuel more quickly, reaching the end of its life sooner and leaving behind a compact white dwarf. These white dwarfs, while small and dim, can contain the mass of the Sun compressed into an object the size of Earth. If they're close enough to their companion star, their gravity can pull material from it, creating detectable signals. The recently mapped stars, Draco C1 and Lin 358, have orbital periods of about 3 Earth years and just over 2 years, respectively. These measurements represent the first complete orbital observations of any symbiotic star systems outside the Milky Way. Understanding these systems helps astronomers learn more about star formation in distant galaxies. In some cases, the white dwarf can siphon off enough material from its partner to trigger a supernova, an incredibly bright explosion that can be seen across the universe. These supernovae serve as standard candles for measuring cosmic distances, and while Draco C1 and Lin 358 aren't likely to explode soon, studying them will improve our understanding of how these phenomena evolve. Now, let's shift gears to one of the largest stars known, Scuti, located about 9,500 light-years away. This gigantic star is roughly 1,700 times the size of our Sun. If placed in our solar system, it would extend beyond the orbit of Jupiter. Scuti is a red supergiant, shining with a brightness about 340,000 times greater than our Sun. So how does a star like Scuti form? It begins as a cloud of gas and dust that collapses under its own gravity, heating up until nuclear fusion ignites. It's not the only massive star out there. VY Canis Majoris, once thought to be the largest, measures about 1,400 times the size of the Sun and is located around 5,000 light-years away. But even these colossal stars aren't the largest objects in the universe. Adding to the cosmic mystery is the Great Attractor, a gravitational anomaly pulling everything in our local group of galaxies toward it. The nature of this attractor remains unclear, but some theories suggest it could be a massive cluster of hypergiants. Speaking of unusual stars, astronomers have recently identified a heavy metal subdwarf, a star with an astonishingly high metal content dot containing about 10,000 times more iron than our Sun. Scientists utilize spectroscopy to analyze its light and determine its unique composition. Then there's Vega, one of the brightest stars in our night sky, located only about 25 light-years away. Vega is a relatively young star, just a few hundred million years old compared to our Sun's 4.6 billion years, with a scorching surface temperature of around 17,000 degrees Fahrenheit. It's much hotter than our Sun. Vega is also surrounded by a debris disk, thought to be similar to the one that once encircled our solar system. Moreover, Vega has even made a name for itself in pop culture, often featured in movies and books due to its brightness and fascinating characteristics. That's it for today. If you enjoyed this cosmic journey, give it a like and share it with your friends. For more fascinating content, check out these other videos and keep exploring the wonders of the universe.